So once we start dealing with multiplication relationships, I like math a lot more. I think multiplicative properties and multiplicative relationships are such an interesting thing. Way more interesting than addition and subtraction. But before we really get into the meat and potatoes of what we're going to do this year in 5th grade math, I want to talk a little bit about patterns in multiplication. I'm going to give you a quick second, a hot second, and I want you to do these things and see if you recognize a pattern. 1 times 3, 10 times 3, 3 times 100, 3 times 1,000. Go ahead, do it right now. Don't wait for me, do it. Pause the video and do it. Alright, so what you should have found, of course, we know that 3 times 1 has a value of 3. We know that 10 times 3 has a value of 30. 100 times 3 has a value of 300. 100 3 times is 300. And then 1,000 times 3 has a value of 3,000. I want you to jot down right now a sentence or two. And is there a pattern that you see going on? Remember, we have a base 10 number system. A base 10 number system has allowed us to do all of these great things with numbers. But what do you see happening in that base 10 number system? Pause the video again, jot down a couple sentences. I would hope what you guys saw is that with every time we increase the place value of this, that we added an extra 0. Okay? Now, we've been talking about exponential notation. If we rewrote this with exponential notation, this could really be expressed as 10 times 0, is 10 to the 0 power times 3. Anything to the 0 power is 1. You don't need to really know that until like 9th grade, but still, right now, just so you know, anything to the 0 power is 1. This can be expressed as 10 to the 1st power times 3. We're going to have a tens and have it 3 times. Of course, 100 is 10 squared times 3, and 1,000 is 10 to the 3rd power times 3. What we looked at last week was that the number, whatever the exponent is, that's how many extra zeros you have after your real value number. If you didn't jot that stuff down, jot it down here in your sentence form now. I want to know, does this pattern work for our larger numbers? Is 23 times 1 23? I would hope. And that could be written as 10 to the 0 power times 1. Or, excuse me, not times 1, times 23. 23 times 10. 23 times 100. 23 times 1,000. I would like you to actually check, instead of just putting 230, 2,300, or 23,000, because 23 1,000s is 23,000. I would actually like you to take the calculator function on your Tier 3 laptop and test these three to make sure that they work. Pause it again. When you confirm that they work, hit play. So now that we've confirmed that they work, let's do it patternless. This is what I tell children all the time. Multiplying by anything with a base 10 number is simple with these extra zeros, because you just take all of these extra zeros and you FedEx them down to your answer. There's 3 total zeros in your 2 factors combined, so there's going to be 3 total zeros in the product. Then I could just multiply 6 times 3. That's going to give me 18. Bam! I don't have to do the adding, I don't have to do the place blocker, but this only works with the extra zeros at the end. Do you see that? Give you another one. It's always good to wear fleece because it can be an eraser. We're going to do 450 times 60. I'm going to take these zeros, I'm going to FedEx them straight down, ship them down to the bottom of the answer right away. Now I just got to do 45 times 6. 6 times 5 is 30. 6 times 4, 24 plus 3, 27. If I do it the long way, you're going to see the same thing. 0, 0, 0, place blocker, 0, 0, 3, 2, 7, 0, 0, 0, 2, 7. Ba-bam. The big idea is that you can just multiply the numbers with a value and put all the zeros down into the bottom. What I'd like you to do is I'd like you to do these three triads. 67 times 100, 300 times 9,000, 415 times 3,000. All right? We're going to look at them tomorrow and we'll discuss them as a group. Oh wait, there's a challenge slide. So, I also want you to do this. I bet you thought you were done. If we know that 1 times 3 is 3, and we know that 10 times 3 is 30, and we know that 100 times 3 is 300, and we know that 1,000 times 3 is 3,000, if we're not sure about that, please rewind and go back to the first slide. I want you to consider this and try it. And try it means try it. What is 1/10 times 3? What is 100th times 3? And what is 1,000th times 3? Pay particular attention to the decimal place that I added in these four numbers. See you tomorrow.